In physics, we aim to understand the universe and all of the things in it, from stars and galaxies to atoms and particles. In the pursuit of this knowledge, we often have to carry out calculations to analyse phenomena in more depth than just using words. Sometimes these calculations can be quite complex and daunting at first glance, but in this video we're going to look at the process that will make them simple and intuitive. This process is called the NURS method, which is an acronym for the four main stages. The first part of the process is called numbers. What we do here is to write down all of the information we have in the question into a neat bullet point list. Each item in the list should have three things: the symbol of the variable, for example R for resistance or F for force, the numeric value, and the unit associated with it. You should also include the symbol of the variable you're being asked to calculate. This is all information you're given in a typical calculation question. Now we know what variables we're dealing with, we can use our list of variables to identify the equation that links them together. This can often be the hardest step of a calculation, as if you can't find the right equation, then you stand little chance of getting to the right answer. The next step is all about units. Now we need to look carefully at our list of values and check that they're all in standard units. This is important because if you put a value in the wrong units into the equation, then you can get a completely different answer. To convert units, you need to know the unit prefixes and how they affect the value they're associated with. You can see some of the common prefixes on screen now. Not every question requires this step, but it is important to check, as there's always a mark available if a unit does need to be converted. Next up is the replace step. Now we've identified our values and converted their units where necessary, we need to put them into the equation. It's important to make sure you put the right values in the right places here. Use the variables list from the numbers step to help with this. The final step is switch. This part is only necessary if after carrying out the replace step, the unknown value you're trying to calculate is not the subject of the equation. If it is the subject of the equation, then you can go ahead and skip this one. Otherwise, to rearrange the equation, you need to get rid of everything that's on the same side of the equation as the unknown. For example, here x is not the subject of the equation as it's being multiplied by 3. We need to remove this to get x on its own. To do this, we do the opposite operation to both sides. As we have a multiply by 3 currently, we need to divide both sides by 3 to remove it. After carrying out these 4 steps, you'll now have an equation which you can key into your calculator to get an answer. Let's apply this to a simple question to see how it works. The bulb is connected to a 12-volt power supply. Calculate the power of the bulb when the current through the bulb is 1.5 amps. So the first thing we need to do is to get the information out of the question and identify the equation we're going to use. We know that the potential difference across the bulb is 12 volts and the current through it is 1.5 amps. We've been asked to calculate the power, so let's add that to the list. Now we need to identify an equation linking P, I and V, which leads us to P equals I times V. Next, we need to check the units. The standard unit for potential difference is volts, which is what we have. For current, it's amps, and again, that is what we've been given. No units need converting this time, so we can tick off the units step. Now we need to get those values into the equation. Power can remain as the letter P, as we don't know what its value is yet. Then we have an equals, then current, which is 1.5, then a times sign, and finally potential difference, which is 12. In this case, we don't need to use the switch step, as our unknown is already the subject of the equation, all on its own on the left-hand side. All that's left is to put this into a calculator to get our answer of 18. We must not forget the units for our answer though. As we've put standard units into the equation, we'll get standard units out. So for power, this will be watts. Now let's try a more complex question that makes use of the units and switch steps of NURS. The extension of the spring was 12 centimeters when the force was 3 newtons. Calculate the spring constant of the spring. As before, we start by getting the information from the question. This time we have an extension of 12 centimeters and a force of 3 newtons. We're trying to find the spring constant, so let's add that to the list. The equation linking these is one from the forces topic, F equals KE. Now we check the units. Force is okay, but extension is not. Any length or distance should be measured in meters, but we have centimeters. So we must rectify this before we start using it in any calculations. There are 100 centimeters in a meter, so we'll need to divide by 100 to get our value into meters. Now we have our converted values, we can substitute them into the equation. Force is 3, then equals, spring constant is unknown, so leave it as a k, then a times sign, and we use our converted value for the extension. Looking at this equation, it's clear it's not something we can put into a calculator yet. The unknown is not by itself on one side. To correct this, we need to move the 0.12 from the right side to the left. We can do this by doing the opposite operation. At the moment, we're multiplying by 0.12, so we need to divide both sides by 0.12 to move it over. After doing this, we're left with 3 divided by 0.12 equals k. Now we can put this into a calculator and get an answer of 25. Again, standard units have been used, so we'll get 25 newtons per metre. Now we've gone through 2 examples, hopefully these calculation questions are starting to look a little less scary and a bit more approachable thanks to this simple method. Now, go and give it a go yourself with a question of your own, and rewind the video if you need to recap a part of the method as you go.